All right, hey guys, Mr. Kyle Myers Mathematics, and let's just jump into it. We're going to find an explicit formula for a sub n where a sub 1 is equal to 1 and a sub n is equal to a sub n minus 1 plus n for n greater than or equal to 2. All right, a little bit of a mouthful, but yeah. So this is actually, I think this is the same as like number 3 as far as the thing goes. But this is, I think we actually did the numbers for this, but let's go ahead and do them again just in case you didn't get assigned number 3 or whatever. So if I have n, when n is 1, so when n is 1, a sub n, as in a sub 1, is 1. Okay. If I have a sub 2, if I want to know what a sub 2 is, we only need to get a pattern going here. So I'm only going to do maybe out to like 4, just to try to establish a pattern here. So a sub 2 would be a sub 2 minus 1 plus 2. Make sense? I'm just plugging in 2 everywhere saying in. So if I want the second term in the sequence, then that would be the first term in the sequence plus 2. Well, the first term in the sequence is 1, so it's 1 plus 2, which is 3. Okay, we got a 3. Now, I want to know a sub 3 next. A sub 3, so I'm plugging in 3 for n. So I plug in 3 for n, plug in 3 for n. Okay, well then that's going to be a sub 2 plus 3, and a sub 2 we found out was 3. 3 plus 3, which is 6. Okay, a sub 4 is going to be a sub 4 minus 1 plus 3, which is, oh, sorry, plus, going a little too fast here, almost made a mistake, plus 4, because I'm plugging in n, equals 4 there. So then that's going to be a sub 3 plus 4. A sub 3 is 6. 6 plus 4 is 10. Okay, so let's see what the pattern, what is the pattern? Okay, well, I'm adding 2 or timesing by 3. But if I times by 3, then I'd have to keep timesing by 3 maybe, and that wouldn't really work out. But what if I add? If I add 2, well, I can't just keep adding 2, but what if I add 3? Okay, so add 3. What if I add 4? Okay, so add 4. And that is actually what's happening, right? I mean, I'm basically like starting with the previous term, and then I'm adding like 1 more to it. It's plus n, so it's plus a bigger number each time. So the pattern of the pattern is plus 1. And that's really important. So if you just have an adding pattern, then it would be what's called an arithmetic sequence. If you had a timesing pattern, like I would be timesing by 3 every time, then that would be a geometric sequence. But I have a pattern to a pattern. So if you have a plussing pattern or a minusing pattern, if you're adding a negative, whatever you want to call it, if there's a pattern to the pattern, then it's not linear, it's quadratic. So if the pattern is here, then that would be linear. Or you could say it's an arithmetic sequence. If the pattern is here, then it's quadratic. Quadratic. If the pattern was on the next level over, then it would have been a cubic, and so on and so on and so on. So since the pattern is here, I'm plussing 1 every time on that level. Then it's a quadratic. So it's going to be like an x squared kind of thing. So then a sub n is going to be some sort of quadratic. Now I'm using n for x basically. So it's going to be like some sort of n squared thing. Right? N squared or something. We got to figure out what the something is. Okay, so we know that's like the base is n squared. Well, what if I just do n squared? Like, what would happen? Okay, well, n squared, so that would be like 1 squared is 1, 2 squared is 4, 3 squared is 9. It looks like that would already be kind of close. Because n squared would be n and n squared. So 1 is 1, 2 is 4, 3 is 9, 4 is 16. And we kind of already have something like that, like 4, 9, let's see, how close are we? Like 4 and 3 are 1 away, 9 and 10 would be 1 away. What if we did like n squared? What if we did -1? So +3 +4. Gotta get it where it works here. Oh, you know what we could do is we could just brute force it, because I could say that this is, I'm gonna have some sort of coefficient here. Let's call it like coefficient 1, coefficient 2, coefficient 3. Like ax squared plus bx plus c. I could just do it that way. That would be like a very brute force way to do it, though. I don't know. We can resort to that if we need to, but let's see if we can do something fancier. Let's see if we can just kind of get a fancier way here. What if? Okay, so the first term is, well, we don't really do the pattern until after the first term. So it's really like the 4, the 9, the 16, where we have the thing going on there. So what if we did half? But half wouldn't always work because it's like an in. It is like an even and then an odd, even, odd, even, odd. So it keeps changing. We could minus, because it gets a little bit too big. Like 4 compared to 3, 9 compared to 6, and then 16 compared to 10. That's 1 away, and then 3 away. 1 away, 3 away, 6 away. That's like literally what the pattern is already. Grr. What if we went backwards? Let's do that. So if we went backwards, then it would have been like, if n is 0, then that pattern would have been like adding, I would have added 1 to get to 1, so that'd be 0, 0. Because that would have been +1, and then that would have been +0, so it would have been 0. So it looks like the vertex is somewhere around, because those would be like the x-intercepts. Ooh, let's try that. Because those would be the x-intercepts. So the x-intercepts are 0 and -1, so it'd be n +1. Would that work? Let's see, n squared. But that's n squared plus n. That should be too much, not too little. Let's see, unless you just kind of like back it up a little bit. So that would be plugging in 1, I would get 2 though. Oh, darn. Okay. But that would be the 2 intercepts. There's got to be a coefficient I'm missing though. Let's see. So I might just be missing a coefficient at this point. So n squared plus n. Let's see what that would be. N squared plus n. And I'm doing, okay, so I just plug in 1, so that'd be 1 plus 1 is 2. And then that'd be 2 squared is 4. 4 plus 2 is 6. Then I would be doing 3 squared is 9. And then 9 plus 3 is 12. 4 squared is 16. Plus 4 is 20. What if I took half? Half? That works. If I take half, that works. So it's a 1/2 times this. So it's 1/2 times that. There we go. So it's like 1/2 of that, 1/2 of that. Okay, we got it. Hey! Okay, so if you want to see, like, just let me know in the comments if you want to see that other method, because what I was going to do is a brute force way, which is like a probably overkill. But I would basically solve for like the coefficients by plugging it into like a matrix is what I would have done. Yeah. So let me know if you're watching this and you want to see what that other method is. The other method works, but it's a little much. It's like if you need to chop down a sapling of a tree and you use like a high-powered chainsaw, and it's like, okay, that wouldn't have taken that many chops of of like an axe, but you took a chainsaw and you just ripped it. But I mean, it would also like take a little bit to set it up too. So I guess it's not quite the same thing. Anyways, not the point. Let me know in the comments if you want me to show you what I meant by the brute force way to do it. But we found the pattern. The pattern is 1/2 in parentheses n plus 1 close parentheses. That's probably the better way to write it, is like that. So, whoo, there we go. That one was a little bit harder that time. That was a little harder. Oh, by the way, if you know a better way to do it, then let me know. Because it is possible that there was a faster way to do that one. But yeah, just let me know. Give me some feedback. Give me some love. And I'll catch you guys in the next video. Check out my website if you want to see other content that's on there. I have a PDF called the 5 Math Mistakes Everyone Makes and How to Avoid Them. Or you can just check out other videos in the series here on YouTube. You can also email me if you have any questions about like tutoring or anything else that I do. That's also in the description down below. So go check it out, and I'll catch you in the next video. Blessings, y'all.